Hello, this is Math 236. Today we talk about the examples of Chapter 2 homework. Examples of Chapter 2 homework. Chapter 2 we will learn its limit and the derivative. First question, find the domain of the function f of x equals square root of 9 minus x. So since this square root 9 minus x under square root 9 minus x need to be greater than or equal 0, positive or 0. If a negative, then the function value is going to be an imaginary number. And here we don't talk about imaginary number, we talk about real number for the function value. So we have to let this 9 minus x greater than or equal 0, positive or 0. Then we solve for the x, add x both sides, and we'll get 9 greater than or equal x, and rewrite is x less than or equal 9. So the domain of the function is going to be less than 9. So write in interval notation is from negative infinite up to 9, including 9. So use the bracket. That's because it have equal sign. So use bracket. If there's no equal sign, use the parenthesis. For example, find the domain of g function. G is the square root of 6x squared plus x minus 15. And in order to make g of x function value real number, not imaginary number, so this square root of 6x squared plus x minus 15 need to be positive or 0, greater than or equal 0. So then we factor this. Since how to factor 6x squared plus x minus 15. How to factor 6x squared minus x plus 15. Factor it. Here it's plus x minus 15 greater than or equal 0. This one. So first of all, we find out. We factor 6. 6 can be factored as 1 times 6 or 2 times 3. And then we factor negative 15. Negative 15 we can factor as 1 times negative 15 or negative 1 times 15 or 3 times negative 5 or negative 3 times 5. There's no more. So first of all, we write down on first column, we write down factor of 6. Normally we choose the two numbers close to each other. Try it first. 6 factor as 2 times 3, put on the first column. And 3 and negative 5, the 2, 3, and the 5 closer than 1 and the 15, so closer to each other. So put 3 and the negative 5. Then we do times together. 3 times 3 is 9. 2 times negative 5 is negative 10. We want add together. Add together is equal negative 1. And this one need to be matched with x-term coefficient. Here x-term coefficient is a positive 1. So this one is not right factor. But if I switch the sign, is 2, 3 here, 2, 3, and switch. 3 become negative 3, 5 become positive 5. Switch the sign. Then cross times it. 2 times 5 is 10. Negative 3 times 3 is negative 9. Add together, the sum is a positive 1. This one is a match with x-term coefficient positive 1. So this is the correct one. Then attach with x. Because this 2 times 3 is 6. Is come from x squared term. X squared separate x times x. So 2x times 3x is 6x squared. Negative 3 times 5 is negative 15. Cross multiplication, 2x times 5 is 10x. Negative 3 times 3x is negative 9x. Add together is the middle term, x. So this is the right one. So then put the parentheses. So this factor as this one factor as 2x minus 3 times x plus 5 greater than or equal 0. So factor as I write them over here, 2x minus 3 times 3x plus 5 greater than or equal 0. Now then find the solution. How to find the solution for this inequality? First of all, equal 0. 2x minus 3 times x plus 5 equals 0. Two solutions. One is 2x minus 3 equals 0. The other one, or x plus 5 equals 0. This we call zero factor property. The two factor times together equals 0. Then either first factor equals 0, 2x minus 3 equals 0, or second factor, x plus 5 equals 0. Then solve for the x. Add 3 both sides divided by 2. Get x is 3 over 2. Or minus 5 both sides. Get x equal negative 5. So that's 2. Make equal 0. Make equal 0. And then we draw a line. Put the smaller one is negative 5 on the left. The larger one to the right. Put it in a real number line in order. On the left side is smaller, is less than the right side. Then always positive, negative, positive, which is greater than or equal 0, will be fall in the positive interval, this side. Any number greater than 3 over 2, like this 1 and 1/2, like 2. 2 is greater than 1 and 1/2. Then you plug in. Plug in. Make 2 times 2 is 4. Minus 3 is positive 1. 2 add 5 is 7. Positive. Time together is positive. Greater than 0. So any number greater than 3 over 2. 2x minus 3 is positive. X plus 5 also positive. Time together is positive. So this is the solution. Make this positive. Any number less than negative 5, you plug in, like a negative 6. 2 times negative 6 is negative 12. Minus 3 is negative 15. It's negative. Negative 6 add 5 is a negative 1. So negative times negative become positive, greater than 0. So any number less than negative 5, make 2x minus 3 negative. Make x plus 5, the two factor, both negative. Time together become positive. So that is also solutions. So then you answer the solution is from negative 15 up to negative 5. And including negative 5, because they have equal sign, so including negative 5. Union with from 3 over 2 up to positive infinite. Up to positive infinite. So that's the if greater than or equal 0, solution is the two union together. If less than 0, the solution is between the two number. So this is for first question. Then the second question. Second question, evaluate the limit. Limit 5x minus 3, x approach to 0. So you just put the 0 into x, and you got 5 times 0 minus 3. 5 times 0 is 0. 0 minus 3 get negative 3. So limit, when x approach to the 0, the 5x minus 3 is approach to negative 3. So limit is a negative 3. And B, limit x approach to 1 from positive side is from right side of the 1. Approach to 1. So here, first of all, you cancel x minus 1, x minus 1. Common factor, cancel. Cancel the common factor. Cancel. And we'll get limit x approach to 1, 1 over x. And plug 1 into the x, get 1 over 1. So the limit is 1. Cancel common factor. And C, for the limit of x approach to infinite, 3x squared plus 2x plus 4. And here, 2x squared minus 3x plus 1. Now you both sides, numerator divided by x squared, denominator also divided by x squared. Then each term divided by x squared. 3x squared divided by x squared gets 3. 2x divided by x squared, cancel 1x and get 2 over x. Plus 4 divided by x squared, get 4 over x squared. And 2x squared divided by x squared cancel, get 2. Minus 3x over x squared, cancel x, get 3 over x. Plus 1 over x squared. Then when x approach to infinite, 2 over infinite is approach to 0. 4 over x's approach to infinite, very, very big number. 4 over infinite also approach to 0. 3 over infinite also approach to 0. 1 over infinite also approach to 0. So you got 3 plus 0, add 0, get 3. 2 minus 0, add 0 is 2. So actually is leading, there's a quick way to do. If the numerator and the denominator degree are equal, this degree is 2. Degree is the highest exponent. So this numerator polynomial degree highest exponent is 2. So this polynomial degree is 2. Leading coefficient, highest exponent term coefficient 3. We call leading coefficient of this polynomial. And the denominator, the highest exponent is 2. This is 1. This is 0. X to the power 0 equal 1. So constant term degree is 0 for x to the power 0 because x to the power 0 equal 1. So highest exponent also 2. That's 2 is the degree of this polynomial. Leading coefficient is the highest exponent term. This term, coefficient, we call leading coefficient. If the two polynomial, numerator, denominator, have the same degree, equal degree, then when x approach to infinite, and this divided, this rational expression, rational means a fraction, rational expression is approach, limit is approach to leading coefficient divided 3 over 2, 3 over 2. And that is the quick way to do. If the numerator and the denominator have the same degree, when x approach to infinite, the limit is 3 over 2. Leading coefficient divided. Then you don't need to do this procedure. That's a quick way to do. Next question. When x approach to -2, first of all, we factor numerator and denominator. X squared minus 2x minus 3, we find two numbers timed together equal -3. Like -3 times 1 or 3 times -1. And the two numbers add together equal -2. So only -3 times 1 is -3. -3 add 1 is -2. So the factor is x minus 3 times x plus 1. You can check it by FOIL. X times x is x squared. And the outer term product is x. Inner term product is -3x. Combined is -2x. Last term product, -3 times 1 is -3. So you need to find two numbers timed together, denominator. Two numbers timed together is 6, like 2 times 3 is 6. Or -2 times -3, also 6. And the two numbers add together need to be 5. So 2 add 3 is a 5. So factor is 2 and 3. X plus 2, x plus 3. And then cancel the common factor. So are there any common factor we can cancel? No, there's no common factor we can cancel. So we plug in. Approach to -2. X, use -2, plug in x. -2 minus 3. -2 add 1. -2 add 2. -2 add 3. So the -2 minus 3 is -5. -2 add -3 is -5. -2 add 1 is -1. -2 add 2 is 0. -2 add 3 is 1. 0 times 1 is 0. -5 times -1 is a positive 5. 5 divided by 0. Denominator is approach. This is just approach to -2, not exactly -2. So you plug it in, will be 0. And so that makes the denominator approach to 0. Because this one's approach to 0. Time together is very, very small. So 5 divided by very, very small become very, very big, become positive infinite. So, and we say, you can put positive infinite, or you can say it doesn't exist. The limit doesn't exist, or you just put positive infinite. As long as the infinite is a positive infinite or negative infinite, that limit doesn't exist. Another example, example 2, limit x approach to 3. That limit, so no matter what kind of x, the value is always 3. 3 is constant. So limit is 3. Doesn't change. Doesn't change. Limit is a constant. And another example, next example, x squared minus 4 factor. Use the formula. Formula is a squared minus b squared equal to a minus b times a plus b to factor x squared minus 4. X squared minus 4 is x squared minus 4 is 2 squared. So x is a, b is 2. X is a, b is 2. Plug in. We'll get x minus 2, x plus 2. And use this formula to factor it. So x squared minus 4, and we'll factor as x plus 2 times x minus 2. Denominator is x plus 2. X plus 2 cancel. So you got limit x approach to -2, x minus 2. And the -2 plug into x. Get -2 minus 2, which is -2. Add -2, get -4. That's limit. Next example. B plus 1 over b plus 3. When b approach to -3. Then when you plug in, b is -3, plug in. b use -3, plug in. -3 add 1 is -2. -3 add 3 is 0, which is denominator approach to 0. This is just approach to -3. It's not exactly equal -3. So then very, very close to -3. When you add 3, it's very, very close to 0. Very, very approach to 0. So denominator become very, very small, approach to 0. And the numerator approach to -2. When we divided, -2 divided by very, very small number, become very, very big number we call negative infinite. You can answer negative infinite. Negative infinite. You can answer negative infinite. Or you can answer does not exist. Limit. If the limit is infinite, like this one is infinite, and this one is Negative infinite. Infinite is not a number. It's just a status situation. So that limit is not a number. So limit doesn't exist. Also, or if you just put a negative infinite and doesn't say does not exist, it's okay. You just put negative infinite or positive infinite. It's okay. The next question, limit x approach to 9. Square root of x minus 3 over x minus 9. First of all, we can factor x minus 9. X minus 9. How to factor? Use this formula to factor. X minus 9. Since x is equal square root of x squared, a number takes square root and square is still x, because square root and the square are inverse operation to each other. And minus 9. 9 is 3 square. Then use this formula. A use square root of x. B use 3, plug in. So we got square root of x minus 3 times square root of x plus 3. Factor it. So over here, we factored. Get this square root of x plus 3 times square root of x minus 3. Numerator is the square root of x minus 3. The two are common factor. Cancel each other. So become 1. So become limit x approach to 9, 1 over denominator, square root of x plus 3. Then 9 plug in. Square root of 9 plus 3, 1 over. 9 is 3 squared. Take square root is 3. Plus 3 is 6. So answer is 1 over 6. The next one, limit this. Also, 4 minus x squared, we can factor by the formula. 4 is 2 squared. So factor is 2 minus x times 2 plus x. Denominator, x squared, x cubed. Common factor, x squared, factor out. 2x squared divided by x squared remain 2. And you can distribute it in, is still 2x squared. X cubed divided by x squared remain x. If you distribute it in, x squared times x is x cubed. So common factor is pick up the lowest exponent 2. And you get greatest common factor x squared. X squared. 2x squared divided by x squared cancel, get 2. X cubed divided by x squared become x 3 minus 2 is 1, so it's x. So remain factor is x squared take out, remain 2. Put it in parentheses, plus x cubed divided by x squared remain x. Put it in parentheses. Then common factor 2 plus x cancel each other. So then we got limit x approach to negative 2. 2 minus x over x squared. Then negative 2 plug in. Got 2 minus parentheses x use negative 2 plug in. X use negative 2 plug in parentheses square. So 2 add 2. Negative become plus. Get 4. And the negative 2 square, negative 2 times negative 2 is 4. 4 over 4 equal 1. So this, the next page, continue the limit. So E, problem 2, continue. Limit the 2 divided when x approach to negative 1. So first of all, you factor x squared plus 4x plus 3. You need to find two numbers times together equal constant term 3. So 3 factor is 1 times 3. 1 times 3 or negative 1 times negative 3. But you need two numbers add together equal 4. So only 3 and 1 add together equal 4. So factor is x plus 3, x plus 1. This also 2 factor as 1 times 2. Tying together is 2. Add together 1 add 2 is the x term coefficient 3. So factor is x plus 2, x plus 1. Cancel common factor x plus 1. And when x approach to -1, you plug in x, use -1 plug in, get -1 plus 3. X use -1 plug in, get -1 add 2. -1 plus 3 is 2. -1 add 2 is 1. Divided, get 2. Then next question. When x approach to 1, negative side is the left-hand side. And from 1, approach to 1 from left of 1. So which is approach to 1 from left side is less than 1. X is less than 1. And factor this. So first of all, factor x minus 1. Now x minus 1 is the same procedure on factor x minus 9. Because x minus 1, x is the square root of x squared. Square root, square, cancel each other is x. Minus 1, 1 is 1 square. And use the formula. The formula is a squared minus b squared equal a minus b times a plus b. Now here a use square root of x plug in, b use 1 plug in. So you will get square root of x minus 1 times square root of x plus 1. So here, x minus 1, we factor as square root of x minus 1 times square root of x plus 1. And then cancel common factor. Square root of x minus 1, cancel. Then x approach to 1. Then we use 1 plug in. 1, square root of 1, add 1, and 1 over. So it's 1 over 2. And the next one, x approach to negative infinite. Negative infinite. So this question you can do another way. And this is one way to do. You do numerator divided by denominator. X squared divided by x plus 1. X squared divided by x, get x. X times, and tying together, x times x is x squared. X times 1 is x. Then do subtraction. X squared minus x squared is 0. 0 minus x is negative x. And plus 1. Then you got 2 terms divided. Negative x divided by x is negative 1. And tying together, negative 1 times x is negative x. Negative 1 times 1 is negative 1. Then do subtraction. Negative x minus negative x, 0. 0 minus negative 1 is 1. Then you write down is the quotient. X squared divided by x plus 1 equal quotient x minus 1 plus remainder is 1 over divisor. 1 over x plus 1. Let me show you this. For example, like 7 divided by 2. What you do is you can use 3. And 3 times 2 is 6. And get remainder 1. So 7 divided by 2 is 3. Add 1 over 2. Quotient, add remainder over divisor. And put together 3 and 1/2. So use the same idea. X squared divided by x plus 1. Now you add more term because here x plus 1 is 2 term. You add more term, x squared, then x term put the 0. Constant term put the 0. Then x squared divided by x. X squared divided by x. Cancel x, get x. And then tying together just like this. 3 times 2 gets 6, put over here. So x times x plus 1 put over here. x times x is x squared. X times 1 is x. Then subtraction, just like this, subtraction. X squared minus x squared is 0. 0 minus x is negative x. Bring the next term down and get 2 term divided by the 2 term. So negative x divided by x and get negative 1 and put it on the here, negative 1. Then time together. Negative 1 times x is negative x. Negative 1 times 1 is negative 1. Then do subtraction. The two are same. Subtraction is 0. Then 0 minus negative 1 becomes 0 plus 1. So remainder is 1. And then put down quotient. Quotient is x minus 1. Add remainder 1 over divisor, just like this. Quotient 3. Add remainder 1 over 2. So 1 over x plus 1. So x squared over x plus 1 become this, equal this. So we got x squared divided by x plus 1. That equals quotient x minus 1 plus remainder 1 over x plus 1. Become this. So when x go negative infinite, x use negative infinite, plug it in. Minus 1, here, minus 1 plus 1 over x use negative infinite, plug it in, plus 1. Negative infinite plus 1 still negative infinite. 1 over negative infinite become approach to 0. Approach to 0. Very, very small. So then we'll get negative infinite minus 1 still negative infinite. Add 0 still negative infinite. And you can answer negative infinite. You can answer negative infinite. Or say does not exist. It's okay. There's another way to do. Another way to do is like this, g, limit x approach to negative infinite, x squared over x plus 1. Another way to do is you divide numerator x squared divided by x. Denominator x plus 1 also divided by x. And then become each term divided by x. Limit x approach to negative infinite, x squared divided by x. Get 2 minus 1, which is 1, x to the power 1. And this x divided by x is 1 plus 1 divided by x, 1 over x. Each term divided by x. Then when go to the negative infinite plug in x is negative infinite. 1 plus 1 over negative infinite is approach to 0. 1 over, so is approach to 0. And you got negative infinite over 1, which is a negative infinite. Probably this way is a faster way to do. But there's another quick way to do, the third way. Third way. If numerator degree is greater than the denominator degree, numerator degree is 2, denominator degree is 1. When you divide it, when x approach to negative infinite, the answer is negative infinite. If numerator degree greater than denominator degree, then will be infinite. Either positive infinite or negative infinite is the answer. So in general, let's put this general formula. When x approach to infinite, either positive or negative infinite, the numerator is a polynomial. Degree is n. Leading coefficient is an. Denominator is a polynomial. Degree is n. Leading coefficient is bn. if a numerator degree less than denominator degree, if m less than n, numerator degree is less than denominator degree. The first case, m less than n, when x approach to positive infinite or negative infinite, then the limit is approached to 0. The answer is 0. The second case, if degree are equal, if m equal n, the numerator degree equal denominator degree, m equal n. Limit when x approach to positive infinite or negative infinite, then the limit is approached to leading coefficient divided am over bn. Leading coefficient divided. That's the answer. The third case, if the numerator degree m is greater than the denominator degree, when x approach to infinite, then the answer is infinite. Or say it doesn't exist. It's an infinite is not a number, so we say the limit doesn't exist. And let's see some more examples like this. When x approach to infinite, x squared degree plus 3, numerator degree is 2, denominator degree is 3. The numerator degree less than denominator degree. So when x approach to infinite, the denominator approach to infinite become very, very big because the degree is 3. So therefore, when denominator approach become very, very big compared with numerator is big, too big. So divided is approach to 0. Because divided by big number, the number become very, very small and gradually approach to 0. So another example, like a numerator degree, x squared plus 3 degree is 2. Denominator degree is 2. Same degree. So when x approach to infinite, the answer will be leading coefficient. X squared plus 3, x squared, coefficient is 1. Denominator, coefficient, leading coefficient is 2. Leading coefficient divided 1 over 2 is the limit, is the answer. The next question, next example. The numerator degree is 3. Greater than denominator degree is 2. Numerator degree greater than denominator degree. So when x approach to infinite, then the numerator approach to become very, very large is compared with denominator is larger, is greater than the denominator. And so the numerator is very, very large. And the denominator, compare it, denominator is smaller than the numerator. So divided is approach to infinite. So this is 3 examples and follow the here the rules. And you can use this to do. So like g, go to x go negative infinite, then numerator degree 2, denominator degree is 1. Numerator degree greater than denominator degree. So it's approach to negative infinite. Go infinite, only for the infinite. So like this, infinite. C, infinite. Numerator degree is 2, denominator is 2. Same degree, equal degree. So when x approach to infinite, that will be approach to 3 over 2. Leading coefficient divided 3 over 2. So then question 3. Question 3, we talk about the limit. So there's we call piecewise function. When x less than or equal to, the function use 2x minus 3. If x greater than 2, the function we use negative x plus 3. Evaluate the limit. A, limit x approach to 2 plus. Plus means right side, greater than 2. When x approach to 2 plus means approach to 2 from right side of 2, which is x greater than 2. So x greater than 2, you use second one. X greater than 2, use second one. Plug in, get negative x use 2, plug in plus 3, get 1. So limit is 1 when x approach to 2 from right side, which is x greater than 2. So you use x greater than 2, use second one, 2, plug in x, and get 1. And then B, when x approach to 2, negative. Negative is from left-hand side, less than 2. When x approach to 2 from negative side, which is less than 2, which is x less than 2, from left-hand side, approach to 2. From left-hand side, approach to 2, so which is x less than 2. When x less than 2, and use first one, 2 plug in into the first, get 2 times x use 2 plug in, 2 times 2 minus 3, get 4 minus 3 equal 1. So from here you can see limit x approach to 2 from right hand side, limit is 1, and limit x approach to 2 from left hand side, the function approach to 1. And since they are equal, so we say the limit x approach to 2, the function approach to 1, equal 1. So here is a general form. When limit x approach to a from left-hand side, negative from left-hand side, the function is approach to L. And the equal to when x approach to a from right-hand side plus from right-hand side, the function is approach to L also. If from left-hand side, from right-hand side, the function is approach, the limit is of the function is equal L, then we can say the limit x approach to a equal L. So x approach to 2 from right-hand side is 1. When x approach to 2 from left-hand side, the function is approach to 1 also. From left-hand side, from right-hand side, both are limit is 1. Function limit is 1. Then you can say limit x approach to 2, f of x, the limit is equal 1, approach to 1. So this is a general form. The second then ask you whether this function continues or not, at 2 continues or not. So, and this one, how to determine is continue or not. And if limit, because 2 you plug in x, f of 2 over here equal to, you use this function 2 times 2 minus 3, 2 times 2 minus 3, f of 2, x equal 2, so you use x less than or equal to, use 2x minus 3, plug into 2x minus 3, get 2 times 2 is 4, 4 minus 3 equal 1, so f of 2 equal 1. 1 is equal to limit f x approach to 2 f of x. So therefore, when x approach to 2 f of x is equal 1, equal f of 2, then we say the f function is continuous at point x equal 2. So put it in general, if the limit x approach to a f of x equal f of a, then we say f is continuous at x equal a. So like this question, a is 2. When x approach to f of x, if equal f of 2 is 2, then we say f is continuous at x equal 2. So you look at when x approach to 2, f of x equal 1. And that 1 is equal f of 2. So limit x approach to f of x is equal to f of 2. So we say f is continuous at 2. And you also can use the graph when you draw the, for this function, for the function like this, and you can use the function like this, 2x minus 3. This is f of x equal, that's the y, when x less than 2 and equal negative x plus 3, you can see it. So this one, so when you draw the graph, here, draw the graph, 2, and then you plug in, it's 1 here, 1, this points. And you can try a 3. 2 times 3 is 6, minus 3 is 3. So 3, 3. And less than or equal to, so you use 1. 1, and you got negative 1. 2 times 1 is 2, minus 3. It's minus 3. So you get negative 1. So this point. So here, less than 2. If it goes straight line, it's going to be this.